The topic is gravitation, and this is another class on that. An isolated spherical planet. This is a language which examiners always use. This is an example language which examiners always use, that isolated. An isolated planet has a diameter this much, its mass of this much kg may be assumed to be a point mass at the center of the planet. These two are assumptions: point mass, isolated. Show that gravitational field strength at the surface of the planet is 3.7 Newton per kg. You read the first part, and what something which I say in my every class, that A2 physics is a memory. So that the gravitational field strength means small g. And he's asking for small g. This is the unit of small g. So you have to see what type of data is given to you. Examiners are always impressed if you use some formula from the start. In A2, all formulas are not memory formulas. G is equal to F upon M. If you people can recall this small derivation, you can work out the derivation with me. So you can also quick recall it. This is the formula. He has given us the diameter, so I can find the radius, and he has given me the mass also. The mass is given 6.4 into 10 is to power 23, and radius is equal to diameter upon 2. Get all these values. Put all these values. Good calculations, Ayan, but answer is also matching. Good work. So please continue, and other people can also submit their answers. Zayan is telling me the answer is coming 3.7. Other people also contribute their answers. 3.69. Okay. Good. Now we move to the next part. A stone of mass 2.4 kg is raised from the surface of the planet through a vertical height of 1800 meters. Use the value of the field strength given to determine the change in gravitational potential energy. It has been raised. So this is the surface, this is the center. And it has been raised to a new position. And the new position is 1800 meter. Use the value of the field strength given in it to determine the change in gravitational potential energy. So this is the a rough diagram is there. Do not make any diagram in the actual paper. Do not make any diagram. So I have just shown it for understanding that it is above the surface. Okay, one student gave the answer. Two people gave the answer 1.6. Hmm. 15984. Now, there is a very technical point in this question because normally when we are in a lecture, we say that this formula is not suitable in A2. But why this formula is here, we have used it because 1800 meter is quite smaller than the radius 6.8 10 power 6. Remember this very technical concept that MGH cannot be used always. G is nearly the same. G is nearly the same. So that is why we are allowing the use of G. A rock initially at infinity at infinity moves towards the planet at point P. Its height above the surface of the planet is 3.5 d, where d is the diameter of the planet. This time the separation is much bigger than even the diameter. Now the issue of G will come. Read this question, read this part of the question. Calculate the speed of the rock at point P, assuming that the change in gravitational potential energy all converts into kinetic. It's coming from infinity. We have the value of the diameter already in our hand. So he's saying that gravitational EP is converting into kinetic energy. Kinetic energy is equal to half m v square. Kinetic energy is equal to half m look at this working. This is a possible way to deal with, and we can find the velocity here also. Or we can put kinetic equal to potential, but we need kinetic energy here. So we need to find the velocity. Either we find kinetic energy first, or we can also do one thing, that we can equate the kinetic energy directly to potential. So there are two options we can try. I have used one option. I can also use an option to convert kinetic and potential equated. We have a formula for potential also. Look at this approach also, that it is minus GMM upon R is equal to half M V square. Minus sign should be neglected because otherwise we can't take the under root. This is the escape speed derivation. This is another approach. Both approaches are fine. In this chapter, the in this chapter, remember this concept that in this chapter we always have to consider R as the separation. Look at this diagram now. Separation from the center. That is 0.5 D. Okay, 1771. We got one answer. Remember, separation diameter was given in the start. Diameter is 6.8 10 power 6. The mass of the planet, was 6.4 times 10 power 23. Then you have to take a under root and solve it. Okay, two people gave me 1800 or 1.8 into 10 is to power 3. So we got two answers of 1800. November 14, 43:2. On the axis of the figure, sketch the variation with distance from a point mass of the gravitational field strength G against the distance. G and separation from the center are always inversely proportional. This is the equation. This is the equation I'm using, and it will be a curve. This equation tells us that it will be a curve and it will be like this. So if you have the actual book with you, if you have the book with you, you can copy the book, copy in the book. On the axis, figure 2.2, sketch the variation with speed. Variation with speed of the magnitude of the force on a charged particle moving at right angles to a uniform magnetic field. This is some people must have done with me, some people haven't. So this is a relation between force and speed. So better leave this question for time being because everyone has not done this. Uniform magnetic field. On the axis of the figure, sketch the variation with time of the power dissipated in a resistor. This is again, we haven't done AC, alternating current circuit. Now take out this question. State Newton's law of gravitation. I'm writing the mathematics, and anyone can tell me the statement. So anyone please tell me the statement. The force of attraction between 2 point masses is directly proportional to the masses. Product of the masses is directly proportional to the product of the masses and inversely proportional to the square of the separation from the masses. Force of attraction. सही है. We got good definitions from people. They gave me good definitions. The force of attraction between the 2 point masses is directly proportional to the product of the masses on an object and inversely proportional to the square of separation between them. Zayan gave me this definition, so I copied it here. There is a small attention needed in this. This is a good statement, but we need to improve one thing, that the product of the masses on an object. So we need a rectification here. Now it's fine. The planet Neptune has 8 moons, satellites. Each moon orbits Neptune in a circular path of radius r with a period t. Assuming that Neptune and each moon behave as point masses, show that r and t are related. So I think majority of you people can identify that this is the all-time famous Kepler's third law. So we need to put Kepler's third law here. Gravitational force is providing centripetal force. This is Kepler's third law derivation, one of the most repeating derivation in this chapter. Look at this working. Copy the derivation with me. He is using the mass as mn. So we can also put mn as a symbol. So look at the working. Data for the moon Triton that orbits Neptune and for the moon Aberon that orbits the planet Uranus are given. So we have the data here. Look at the data. Radius of orbit, period of orbit. Use the expression in B to determine the mass ratio. Mass of Neptune upon mass of Uranus. This is a ratio method. So we can make the formula Gmn. So we can put the formula here. Gmn is equal to 4 pi square. 4 pi 4 pi square r cube upon t square. We will tell examiner that look, G T sorry, G and pi are constants. So when you make the ratio, they won't appear. So let's make the ratio here. We put Neptune. So we will put R cube up, 4 is removed, G, and so I will put R1 cube upon T1 square upon R2 cube upon T2 square. I made the ratio like that. When you resolve fraction in a fraction, 1.18. We got one answer. So R1 upon R2, Neptune upon Uranus. So 10 power 5 is coming for both of them. So they will be cancelled. 3.55 upon 5.83. Now make this ratio. Solve this ratio and let me know once you get the answer. I got one answer by now. That is 1.18. Okay, two answers, 1.18. June 15, 42.1. The Earth may be considered to be a uniform sphere of radius 6.37 into 10 power 3 with its mass of this much kg. Concentrated at its center, the Earth spins on its axis with a period of 24 hours. A stone of mass 2.5 kg rests on the Earth's surface at the equator. Using Newton's law of gravitation, the gravitational force on the stone, it is on the surface of the Earth. So it will be taking the whole radius. The mass of the Earth is given and the mass of the object is given. So first make the data and do any necessary conversion. Put all the values. One answer I'm getting is 24.6. Other people also proceed, give their suggestion. 24.6. Yes, Zion, good. So majority people gave me the right answer. 24.6 Newton. Determine the force required to maintain the stone in its circular path. So circular path is basically circular path. ठीक है, 24.6. Circular path means centripetal force. Formula is FR omega square. But I don't have the value of omega. So I'm first trying to find the time period is given to me. Let me know how much omega is coming. Can anyone tell me how much omega is coming? The time period after putting the time period, how much omega is coming? The angular velocity. Acha, 0.26, but final answer is point. Okay, fine. 0.26 is omega. So if you put 0.26 there in the mass equation, the mass of the object is 2.5. I have 24 hours. I have multiplied it in second definitely. That's why I multiplied by 3600. I have multiplied it by 3600 and it should be converted into second. If there is a difference in omega, you people can tell me. What is the force coming up? Acha. 7.27 10 power minus 5. Any other student can contribute what omega is coming? Because the dispute is coming up for omega. But I have shown the conversion. So whatever. So I made this correction. Whatever you put, you will get the force here. So after getting the let me know the final answer, please. The force. Zero 0.08 Newton. Zion, you are getting a big answer. How is possible? 0.08. Nabia, can you increase the significant figures? 0.08 is only a limited sig fig. Any more sig fig? 0.084 is looks fine. Now you have to see this working, that on the surface of the on the point on the equator, examiner had highlighted the equator position. So as we discussed in our class, at the equator, some of the gravitational force converts into centripetal force. So the final force will be not equal. Final force is not all converted into weight. So some of the gravity converts into centripetal force. So I have to subtract the two forces to get the reading on Newton meter. Newton meter means that you are showing the weight. You have to copy this is now copy this solution quickly. Subtract the values and get me the answer. 24.6 minus 0.0842. Subtract it. 24.51. Examiner wants three significant figure. A satellite is orbiting the Earth. For an astronaut in the satellite, his sensation of weight is caused by the contact force from his surrounding. The astronaut reports that he is weightless. Despite being in the Earth gravitational field. Suggests what is meant by the astronaut reporting that he is weightless. The gravitational force, this is a concept we discussed many times. The gravitational force provides centripetal force. So the weight is not felt because gravity is not pulling it. So whatever he is feeling, the sensation, that is the difference between the two forces. So what you will answer that gravitational force is providing the centripetal force. Fg becomes Fc. This is a weightless situation. This is called a weightless situation because all of the gravity is converting into centripetal force. And only is the sensation is coming, that's a difference. Sensation is Fg minus Fc. So we keep it up to here. This question has been done and we will inshallah continue in our next class. Thank you. Allah Hafiz.